go. So listen up really quick. You are going to have notes today. I am out tomorrow. You will have notes next on Friday. Monday's review, Tuesday's review, Wednesday's your test.
So what do we do tomorrow?
Okay?
She's not here.
Wait, are you going on Friday too?
No.
Oh, what's today?
Today's Wednesday.
Oh, okay, never mind.
So you have 1 week from today. 1 week from today.
I already have my notes in order.
So a week from today, you have your notes due and you have your what you want to do. We're going to take page and a half notes. Or front, back, front.
Front, back.
Or back, front. So like exams.
That's so much.
Okay. Alright, here we go. Today is 2-1. It's February.
I don't like this one. I like this one. I only like it because of the chocolate one. Love it.
We're going to talk about independence. Independence. Okay.
Supposed to see Kelly eating my mouth.
Alright, what are different ways to determine if events are independent? Alright. Let's talk about the multiplication rule. We talked about the multiplication rule last week on Friday. And the multiplication rule uses what keyword? And. And the multiplication rule says the probability of A and B is equal to the probability of A given B times the probability of B. That was one of them, right? Could we rewrite it to the probability of B given, the probability of B times the probability of A given B?
Yeah.
Yeah, it's the same thing, right? Right. And we can say that if A and B are independent events, then the probability of A is equal to the probability of A given B. Right? So the multiplication rule says this, right? And if I'm telling you they're independent, then I can replace the probability of A for this one, and vice versa, correct? Does that make sense? So instead of saying the probability of A given B here, I'm not going to say what? Just the probability of A. So the simple version of this is the probability of A and B equals the probability of A times the probability of B. Right? So all it's saying is that if they're independent, well, this is the same as this. And if this is the same as this, then instead of writing that, I can write that. Okay? Now, could I rewrite this to say the probability of B given A times the probability of A?
Yeah.
I could. I could. Right? I could say the probability of B given A times the probability of A. Okay? That is a valid statement. Okay? Alright. So conditional probability. We talked about conditional probability before. And we can say for conditional probability, we can say that the probability of A given B is equal to the probability of A and B over the probability of C. Which is true, right? The probability of, flavor 1 given an ice cream cone is the probability of an ice cream cone with flavor 1 over cone, right? That's how we did those things. So it's the same idea. Remember, your given is always your denominator? Yes? Okay. So I'm just stating what we've done already. Yes? Okay. Now there is a way to test for independence. And this is all stuff we've done. It looks a little different, but it's stuff we've done. But there is a test for independence. And in order to test for independence, we want to say that the probability of A is equal to the probability of A given B. We want them to be equal. If they're equal, guess what? They're independent. Does that make sense? So if I find the probability of A, and I find the probability of A given B, and they're equal, then they're independent. But if I find the probability of A, and it's not equal to the probability of A given B, then guess what? It's not independent. You understand that? Okay. And I can also prove that the probability of A and B is equal to the probability of A times the probability of B. This is just another way to test the same thing. Understand? Are we good? There's lots of equations up here, but we're all trying to prove that it's independent. And if they're not independent, then what's the other word for independent? What's the opposite of independent? Dependent. Right? And we talked about independence and dependence just a little bit before. We didn't go into crazy detail, but we did talk about it. But today, all you're going to do is prove if they're independent or dependent. And why. Got it? Okay, so the first thing we're going to do is we're going to start with examples, but these examples are going to be based on the rule. So example 1 is still based on the rule. And when I say rule, does that mean I'm writing, like, you're picking a bag, a marble, that kind of rule, or am I talking about the actual mathematical rule? Actual mathematical rule. Okay? So we're going to say determine if events A and B are independent. You were told that the probability of A is 2/3. The probability of B is 1/6. And the probability of A and B is 1/9. So we are told that the probability of A is 2/3, the probability of B is 1/6, and the probability of A and B is 1/9. So what are we gonna do? Yeah. No. Are you adding? No, what are we doing? You're multiplying, so do we need common denominators? Okay, no we don't. So, think of which equation up in here somewhere I'm going to use. What's it labeled as? The simple version, right? So it's labeled as the simple version. So you're going to start with saying the probability of A and B is equal to the probability of what? Simple version. Probability of A times the probability of B. Now what do you do? Plug it in. What's the probability of A and B? 1/9. What's the probability of A? 2/3. What's the probability of B? 1/6. What do you do? Multiply, which is what? 1/9 equals 2/18, which is 1/9. So guess what? Yes, same difference. Make sense? Okay. We're gonna do another one. But I have to turn the page slowly, I think. My friend just found a picture of me
I hate that.
from my third year teaching. Cause 5, 6, 6, 7, 7, 8. So where were you guys in 2007?
Like,
Kindergarten, first, second, fifth grade?
Ooh.
your hair looks so much better now.
It was growing up.
I mean, it doesn't look bad.
I like your hair better now. She used to have it long, and I saw a picture.
It was a different hairdresser. I was going, it was shorter after that.
I feel like that hairstyle you have right now makes you look younger. Yeah, because I feel like my mom looks old with short hair. Which is, I guess, yeah, my mom looks really old with short hair.
Okay.
And she has like long hair now, she looks like a teenager.
My hair's long.
It just looks all the way to your face.
Alright, here we go. Second example. Events A and B are independent. Find the missing probability. I am telling you that the probability of A is, I don't know. I'm telling you that the probability of B is 1/5. And then I'm telling you that the probability of A and B is 3/20. So events A and B are independent. Find the missing probability. The probability of A is I do not know. The probability of B is 1/5. And the probability of A and B is 3/20. Young child.
You're like 25
recording.
In the middle of the lesson, her face all set.
That's why I'm on mute. Alright, talk to someone next to you, see if you can set up the equation correctly. Maybe you didn't solve it, but you need to be able to set up the equation correctly.
Oh, there's some, okay, guys.
Well,
Ah. I'm doing simple. I got this lip balm just before it makes my lips so soft. It's like the wrong plastic.
alright, ready? Alright, let's see if you set it up correctly. Are we doing simple version or something else?
Something else.
Simple version. So in other words, the probability of A and B equals the probability of A, turn your phone down, times the probability of B. Yes?
Yeah.
Okay, what is the probability of A and B? 3 over 20. What is the probability of A? Question mark. Or you can call it probability of A, or you can call it,
Times 1/5.
or you can call it what? You don't know something when you call it.
Variable?
X.
Oh.
Okay. Times 1/5. So I'm going to rewrite this to say 3 over 20 equals X times 1/5. Is X times 1/5 the same as saying 3 over 20 times 1/5 X? They're the same.
No.
Yeah, it is. Yeah, I just wrote it weird.
Yeah.
But it's the same thing. Yes? Okay. How do you get rid of a fraction? By the the reciprocal. So you multiply both sides by the reciprocal. What's the reciprocal? 5 over 1. Let's cancel. What is 5 times 3? 15 over 20 equals X. What is it reduced to? So the probability of A is 3.
I did different.
Are we gonna have to do it like that on the test? Really? All I did was I started plugging numbers that would make 20 and then.
Yeah,
No. Just decimals and percents and fractions.
Oh my god.
Can you just go like
Right?
history off?
No. This is a basic equation that you learned how to solve in 6th grade.
No, it isn't.
Well,
Yeah.
yeah, it is.
Tracer.
So I'm not even teaching you anything weird. All I'm doing is telling you, write this is the new part, plug it in. That's all I'm saying, right? Otherwise it's not really new. Okay, so here's another one. And it's going to say that the probability of A is 1/5. That the probability of B given A is something. And that the probability of A and B is 7 over 4. All I want you to do right now is set up an equation. Not even plug it in. Just set up the basic probability equation. Okay? So the probability of A is 1 over 5. The probability of B given A is I don't know. And the probability of A and B is 7 over 4. So all you're doing is setting up the basic probability equation. That means you are not plugging in any numbers. You understand? So when you write that down, right now. Basic probability equation. Check with someone next to you. All you're doing is writing the basic probability equation. I don't even want numbers yet. basic probability equation. Basic probability equation first. Alright, who can tell me the basic probability equation?
Probability A given
No. Who do we start with?
B given.
The probability of A and B.
Oh, okay. Equals the probability B given A times B given
I don't
A.
know.
No, P, probability of A.
Does it matter if I wrote probability of A times probability of B given A? Does it matter if these two flip? No. Because I know that 2 times 4 is the same as 4 times 2, right? There you go. So guess what you do? Plug in. Go. Ready? What is the probability of A and B? 7 over 40 equals probability of B given A. X times 1/5. What do you do both sides? What's the reciprocal?
5/1.
5 over 1. 35 over 40, which reduces to?
7 over 8.
So the probability of B given A is 7 over 8. Yeah? Good?
I always understand how the notes move to the moment when I'm like, what happened? Literally.
I don't know, like, how much does that?
Did you write yourself words that go here?
I write everything.
Yeah.
Not just what I wrote,
Notes to remind you.
that's to remind you what to
Yeah,
do.
I did that one from.
That's what we do. Alright, so let's talk about Y independence. So let's talk about the Y of independence. So events are independent if knowing the outcome of one event has no influence on knowing the outcome of the other. So events are independent if knowing the outcome of one event has no influence on knowing the outcome of the other. When I roll a die, does the outcome rely on the last outcome? No.
No.
They're completely separate, correct?
Yes.
When I flip a coin, does one outcome rely on the other outcome? No, those are examples of independence. Okay? Those are examples of independence. They do not rely on the last thing that happens. If I pick a card at random and I put it back, does it rely on the last one?
No,
No. But if I pick a card at random and keep it out,
it changes it.
it changes. Then it's no longer independent, it becomes what? It becomes independent. Okay? Alright, let's do some examples.
You just flip the page already.
No, that's not.
Example 2 is going to be where we determine
Determine if this is independent or dependent.
whether independent or dependent events. So we're going to determine whether independent or dependent events. Got it? First example. There is a drawer. With 3 pairs of white socks. And 5 pairs of black socks. You randomly pick a pair of socks and put them on the dresser. Then you randomly pick another pair of socks. You get 2 pairs of white socks. There is a drawer with 3 pairs of white socks and 5 pairs of black socks. You randomly pick a pair of socks and put them on the dresser. Then you randomly pick another pair of socks. You get 2 pairs of white socks. Remember what the directions are asking. You don't talk about it, just think of what it is. There's a drawer with 3 pairs of white socks and 5 pairs of black socks. You randomly pick a pair of socks and put them on the dresser. Then you randomly pick another pair of socks. You get 2 pairs of white socks. You good? Raise your hand if you think it's independent. Raise your hand if you think it's dependent. Why is it dependent? Because you put them where? On the dresser. Did I put them back?
No.
No. But I need to prove they're dependent. So, let's talk about it. The first time, in my drawer, I have what?
3
No.
pairs of white.
3 pairs of white socks. So 3 out of what? 3 out of 8. Those are my white socks. I also have what? Black socks, which is the what fraction? 5 out of 8. Good? I pick one. So if what? Why am I assuming they're white?
What do you mean?
Why do I get to assume they're white socks that I picked?
Because you have to.
Because in the end, I have two pairs of what?
White
White socks. And I only picked how many times? Twice. Okay? So I get to assume they're white. So if white, the second time I go to my drawer, what do we have? 2 out of 7. Why did it become 2 and 7?
Took one out and then put it back.
I took one pair of white socks, which goes from 3 to 2, and I didn't put it back, which makes it go to 7. Got it? Black socks, 5 out of 7. Why? Because I didn't put it back. Are these the same? Therefore, they're what? They're dependent. Because why? The probability is what? The probability is change. So in your homework, are you just allowed to tell me they're dependent? No. You have to what? You have to explain it. Is this mathematical explanation as to what?
Yeah, just
Yeah.
like that. Like that.
Yeah. We good? Okay, next one. Example B. There is a basket of candy. On Mrs. Calderon's desk. True story. There are 4 watermelon flavor and 6 grape flavor. So far? You randomly take a piece and get grapes. You return it to the basket. Then you pick again and get watermelon. Okay? So there's a basket of candy on Mrs. Calderon's desk. There are 4 watermelon flavor and 6 grape flavor. You randomly take a piece of and get grapes. You return it to the basket. Then you pick again and get watermelon. I want you to decide if you're independent or dependent and what. Ready? Raise your hand if you think they're independent. Independent. Raise your hand if you think they're dependent. You can explain why you think it's dependent. Okay. Who thinks it's independent? You can explain why. Okay. Well, in Brandon.
Well, because you picked out enough grade and you returned it, so the outcome is the same the second time that you picked out.
Keyword. Return. I return it to the basket. So, in my first pick, what is the probability of watermelon? Over 10. Let's not worry about reducing, okay? What is the probability of grape? 6 over 10. Keyword was what? We return it. So, in my second pick, what's the probability of watermelon? 4 out of 10. What's the probability of grapes? 6 out of 10. Independent or dependent? Which one? Independent. Why?
Because the probability is constant.
Give the probability. Are we good? Other questions? Okay, your homework is broken up into 3 sections. The first part of it is very basic. You plug in and solve. So you're just proving that they're independent, like you see if they're equal. The next part is doing this. The last part is finding the missing piece, like we did in the first example. Okay? You good? For your homework, you do need a sheet of paper, fold it up into 4 boxes, or 8, up to you. There's, I think, 12 questions. So you can do 8 boxes or 4, but it doesn't need to be folded up, and you will get that. You're writing your questions, your summaries, or you're doing your folding of paper. Good?